This is the video for section 3.5, notes, slides 21 through 23. All right, so in section 3.5, we are talking about something called implicit differentiation. So implicit differentiation is used when an equation is not solved explicitly for y. All right, so it is actually defined implicitly, meaning the value of y is not given explicitly, it's actually defined implicitly. So it is an implied value of y. So for instance, look down here at the bottom. It says dy dx, find dy dx if x squared equals 2xy squared plus y. So you'll notice this equation is not in y equals form. Okay, now it would actually be very challenging to put it into y equals form because I have y squared here and I have y. So we'd actually have to like divide by 2x and then we'd have to complete the square and all that, right, to get it into y equals form. And so either we don't want to put it into y equals form or we can't put it into y equals form. And so then we want to use this process called implicit differentiation. All right, so how do we find the derivative of a function that cannot be solved for y? Or I suppose that we don't want to solve for y. All right, so step one is to differentiate both sides of the equation with respect to x. All right, so down here I have x squared on the left side. So d dx of x squared equals, and then I'm going to take the derivative with respect to x of the other side, 2xy squared plus y. All right, so now it says to take the derivative, right, or to differentiate. All right, so on the left side, what is the derivative with respect to x of x squared? Well, that's just 2x equals. All right, now on the right side, I have the derivative with respect to x of 2xy squared plus y. All right, so first of all, let's start with 2xy squared. This is a product, right? The product of 2x and y squared. So the derivative with respect to x is going to be what? Well, it's going to be 2x product times the derivative of y squared. Okay, so what's the derivative of y squared with respect to x? It's 2y times, don't forget about the chain rule, dy dx. Right, that's first part of the product rule, u v prime, plus, now take the second part of the product rule, which is y squared, times the derivative of 2x with respect to x. So that would just be 2. And then plus, now I have, this one's really easy, what's the derivative of y with respect to x? It's dy dx. Right, so that's step one. Step two, collect the terms with dy dx on one side of the equation. All right, so you'll notice I have 2x times 2y times dy dx, and then I have a plus dy dx. Those are the two terms that have dy dx. All right, so I'm going to get those together there on the right side. So let's leave them on the right side. All right, but then I'm going to bring any terms that do not have dy dx to the other side of the equation. All right, so I have 2x on the left side, and then I'm going to subtract 2y squared. All right, which leaves me with, this would be 4xy dy dx plus dy dx. All right, so now what's going to happen? All right, so now step 3 says factor out dy dx. All right, so 2x minus 2y squared equals. So just factor out dy dx. Even if something else is factorable, we only want to factor out dy dx. So I have 4xy plus 1. Don't forget about that. All right, so now that's step 3. Step 4 is simply solve for dy dx. So how do I do that? Well, I'm going to divide by whatever's multiplied by dy dx. So dy dx is going to equal 2x minus 2y squared divided by 4xy plus 1. So now I have dy dx. Now, one thing you'll notice, oftentimes, and most of the time, your dy dx is going to have both x and y inside of it. All right, so that is slide number 21. All right, so now let's move on to slide 22. All right, so slide 22, same directions basically. Find dy dx if x cubed minus 2xy plus y cubed equals x to the fourth plus 4. All right, so we're going to do that first. Then find an equation for the tangent and normal lines at 1, 2. All right, so let's just start with dy dx. All right, so I'm going to take the derivative with respect to x of each side. So d dx of x cubed minus 2xy plus y cubed, and then d dx of x to the fourth plus 4. All right, so on the left side, what's the derivative with respect to x of 3x cubed? Sorry, of x cubed is 3x squared. Then minus. Now I have 2x times y. That's a product. So we're going to take the product rule. 2x times the derivative of y, which is dy dx, plus y times the derivative of 2x, which is 2. Right? Notice I put that in parentheses because we're subtracting 2xy, so we need to subtract the whole derivative. All right, and then plus, now the derivative of y cubed, that is 3y squared. Don't forget about the chain rule, times dy dx. All right, so that's the left side of the equation, equals the right side of the equation. The derivative with respect to x of x to the fourth plus 4, so that would be 4x cubed plus the derivative of 4, which is 0. All right, so now, okay, we are going to do step 2, collect the terms with dy dx on one side. All right, so I have this 2x dy dx, but remember it's a minus, so minus 2x dy dx. Then I've got the plus 3y squared dy dx. And then the other stuff's going to go to the other side. So I have 4x cubed. I have a 3x squared, so I'm going to subtract it, 3x squared. And then I actually have a minus 2y. Right, so I'm going to add it, so 2y. All right, now I'm going to factor out dy dx. So dy dx times 2x plus 3y squared, and then equals, the right side stays the same, 4x cubed minus 3x squared plus 2y. All right, so now last step, divide by whatever is multiplied by dy dx. So dy dx is going to equal 4x cubed minus 3x squared plus 2y, all divided by negative 2x plus 3y squared. All right, so now, what is this? Well, this is dy dx, which is a formula for the slope of the tangent line. All right, so now it says find an equation for the tangent and normal lines. Well, one thing, you already know the point, right? You had to be given the whole point x, y, because we don't have an equation solved explicitly for x or y. All right. So then all we need is the slope. So what is the slope of the tangent line? Now remember, the slope of the tangent is going to be dy dx evaluated at 1, 2. So remember, what does that mean? That means x equals 1, y equals 2. All right, so if x equals 1, so I'm going to take 4 times 1 cubed minus 3 times 1 squared plus 2 times 2. Remember, the y value is 2. All right, and then divided by, let's see, negative 2 times 1 plus 3 times 2 squared. All right, so that's dy dx. All right, and so now I'm just going to deal with that. So 4 minus 3 plus 4 divided by negative 2 plus 3 times 2 squared. So that'd be 3 times 4, so plus 12. All right, so 8 minus 3, 5 divided by negative 2 plus 12 is 10. So 1/2 is the slope of the tangent line. All right, so remember, this is the slope of the tangent. So then that means the slope of the normal line is what? Well, it'd be negative 2. And so the equation of the tangent line is going to be y minus 2 equals slope 1/2 times x minus 1. All right, and then the equation of the normal line. All right, so that would be y minus 2 equals negative 2 times x minus 1. All right, so that is using implicit differentiation to find the derivative, and then, of course, what we know from before, point-slope form. All right, so that is slide number 22. All right, so slide 23, basically the same thing, but now we're dealing with trig. All right, so let's deal with it. All right, so find dy dx if x equals cosine of xy. All right, so first of all right, we have to take the derivative of each side with respect to x. So the left side, d dx of x, and then d dx of the cosine of xy. All right, so on the left side, what is the derivative with respect to x of x? Well, it's just 1, so that's nice. All right, on the right side, the derivative with respect to x of cosine of xy. All right, so remember, chain rule, derivative of cosine is negative sine of xy, right, times the derivative of xy. So remember, derivative of xy with respect to x is found by the product rule. So x times dy dx plus y times the derivative of x, which is 1. All right, so now, in this case, I only have one occurrence of dy dx, so we want to isolate that. So now, there's a couple different ways you can do it. you could take the negative sine xy and distribute here, or you could actually just divide by it to begin with. So if I divide by it to begin with, I get 1 over negative sine of xy, which could be rewritten as negative cosecant of xy. All right, and then equals x dy dx plus y. All right, so now I want to solve for dy dx, so I'm going to subtract y, and then I have x dy dx, and so lastly I would divide by x. So dy dx equals negative cosecant xy minus y, all divided by just x. All right, so that's dy dx. Now, depending on your algebra here, like I said here, we could have distributed the negative sine y and then solved a different way. All right, so depending on the algebra that you looked at, right, your answer might look different. But actually, in this problem, it doesn't really matter because I have the point and now I want the slope. So remember, m tan is going to be dy dx evaluated at the point negative 1 comma negative pi. All right, so now let's do that. All right, so we're putting x equals negative 1, y equals negative pi. So negative cosecant of x, which is negative 1, times y, which is negative pi, minus y, which is negative pi, divided by x, which is negative 1. All right, and so what does that mean? All right, cosecant. All right, negative cosecant of negative 1 times pi. So that'd be negative cosecant of pi minus negative pi. So that'd be plus pi. All right, so what is the cosecant of pi? Well, the cosecant of pi is undefined, isn't it? Right? Remember, cosecant is 1 over sine. So 1 over the sine of pi. Sine of pi is 0. So 1 over 0 is undefined. So what does that mean? The slope of the tangent line is undefined. So what kind of line has a slope that's undefined? Well, it's a vertical line. And so we have a vertical line that goes through the point negative 1 comma pi. So if I have a vertical line going through negative 1 comma negative pi, right? So right here, negative 1, negative pi. What does a vertical line that has that true about it? How do we write that? Well, that's actually just x equals negative 1. And so x equals negative 1 is the equation of the tangent line at negative 1, negative pi. So that is slide number 23.